Jay here, friends. Today we are going to solve this particular problem in which we need to check if array is sorted in an whether it is rotated or unrotated scenarios. So let me describe the problem statement first. We would be having an array that is nums, and we need to return true if the array was originally sorted in non-decreasing order. That means it would be a increasing order. Okay. Then rotated some numbers of positions including 0, otherwise return false. Okay, there may be duplicates in the original array. Okay, fine. This is the actual constraint of rotation. If we want to rotate an array from any point of x, we just need not to worry about it. We would be adding it into the index, then divided by the length. Okay, let me tell you again by some examples. Suppose if we have an array that is something like this: 1 2 1 2 3, then 4, then 5, then 6. Okay, and we need to rotate it from this position, start from this particular position, and append it to the first element of it and shift it to the right. The left portion should be shifted to the right hand side, and the position from where we are going to apply the rotation would be shifted to the uh, left hand side. So if we want to rotate it by 1, then what could be the array? Array will becomes like 6 1 2 and 3, then 4, then 5. Okay, if we again shift perform the rotation by 1 again, then array becomes what? The fifth element, it would come at the front of it, then 5, then 6, then 1, then 2, then 3, then 4. Similarly for the next elements, so it would be the right shift. You can consider it as a right. The moment you are trying to put the element of the right hand side to the first, it would be the one rotation for the right hand side. You can consider it as a right hand side rotation, a right rotation as well. So this would be the rotation. Okay, fine. Let's come to the problem again. So what is the problem statement ask us? We would be having an array. It is returning true, and the explanation of if we sort this particular array, then the sorted array would be 1 2 3 4 5. That could be our original sorted array. Okay, here they have rotated it by x equals to 3 position to achieve the beginning position of this particular array, that is 3 4 5 1 2. Similarly for this, in this case, let's come to the true cases first. This is also the sorted array, and the rotation from where it is started from the 0. So need not to worry, it is already in a sorted array, so we need not to specify anything over here. If we come over here, then we can see that the array is starting from 2. Yeah, we found a point from where it is a non-accepting case, that is 2 1. Then it would not be considered at this particular point. But if we go to the next element of it, 3, if we compare the 3 with 1, yeah, it is sorted. Then 3 with 4, then again it is sorted. But do you think this is the end of the comparison? No. Again we need to compare the last element with the first element, whether it is a point of confusion or the point at which it is getting the right, then we can mark it as a right. The approach would what would be the approach in this particular case? As per the question suggested, that we would be having a single point, a single position, that wherever it is, we don't need to worry about the position first, but it would be a single position from where it can break the uh, rule of sorting. It cannot have more than one position in an sorted array. Okay, let me tell you again it in this particular scenario. Here, if we try to find the position from where the sorted array sorting is eliminated, that is the point of this one. Because if we start comparing from here, then 3 and 4, yeah, true. 4 and 5, again true. If we compare over here, the 1 with 5, this should not be the case of a non-decreasing sorting array. So here we are going to find a one element first break condition, and if we compare one with the next element, that is 1 and 2, then again it is true. And at the end we again need to compare the last element with the first element of the array. It should be either equals to the last element or greater than of it. But why not the lesser than of 2? Why I am although if we put 1 over here, then it should be satisfied. It should satisfy this particular case, because 1 4, then 1, then 4 5, it's true. But at this point of position we are getting breakpoint 1, and if we compare 1 and 2 is again true. But why I am telling that we cannot have a 1 over here? If it is 1, then why we are, because let me come to again over here. So what could be the sorted manner of this particular array in this scenario? In this particular scenario, it would be 1 comma 2 comma 3 comma 4 comma 5. But I am telling you the case in which we would be having the lesser value over here. Then what could be the possible ways of sorting? The 1, and then we need to specify 1 over here, then 2, then 3, and then 4. Okay, 3 is not, 3 would not be present over here in this case. It would be 4, and then it would be 5. Yeah, it is the sorted array. But could you please compare this particular array with the array in which we are trying to give 1 at our original position? That was the 1 4, and then 5, then 1 again 2. Okay, if you try to compare these cases, this is exactly, you can say that this is not the rotated format of this particular array, because whatever you are going to do with this particular array, you cannot achieve by the right rotation of this particular array and achieve this particular array. Because how can you get it? If you try to put 1 over here, then how could you get the 4 just exactly adjacent to it? That is 1 we are getting over here, but we need to get the 4. Either we can get the 4, or we need to have 2 from here, then 2, then 1. So it cannot be achieved. So again we need to, the moment you are trying to put these cases, you just need to compare the last element to the first element again, and the case should be the last element again should be sorry, this again, the last element should be either lesser than or equals to the first element in this, in each cases. Okay, I hope you're getting my point. We The approach, what would be the approach? We need to find total number of breakpoints that I have already told you. Okay, let's write the code that I am telling you, and again I will be writing in a way that everyone can understand. So I'll be starting my loop from 0th index, and it will go until the length of the array. length and then I plus plus. Yeah. And what we need to do is we just need to compare the one element to the next element. So the better approach in the rotational arrays would be we need to check if or whether nums of i plus 1 nums of I plus 1 should be what? Either greater than or equals to. Is it? Is it correct? Yes, it is correct. With whom? With nums of I. The previous element. The next element should be greater than. This should be the case for each scenarios, because if you try to compare with the I plus 1, that is over 4 and 3, yeah, it is correct that we are comparing with the good cases. So we can continue from here. We need not to worry about anything over here. But what if the case of the another tribes? But are you able to compare the last element to the first element in this case? Let's put the last index over here. That is 4. Then 4 plus 1 will become 5. But it will throw the out of index of array index out of bound exception over here. So how will you handle it? Again, you can go over here and use the modulo operation from here and just divide it by the length. Okay, it will make this value to the 0th index at the moment you are trying to test with the last index of it. So now it is everything is okay, fine. Okay, this could be the scenario, but this is the case in which we are getting the correct way. What if I invert it into the this particular scenario, and we can have a variable, a count variable, you can say that is int count, which would be the breakpoint, which will store the total number of breakpoints. So we would be checking how many times that we are getting the, at each moment you would be increasing the count value by 1, and if this particular count value is greater than 1 or greater than or equal to 2, then you can easily return. If it is greater than 1, then you can definitely return false, because we cannot have more than 1 breakpoints. And if we are not getting the value, then we at the end we can easily return the true. I hope you are getting my points. Let us hit the run button over here. Okay, we are getting the compilation error. What is this error? ARR. Okay, fine. This should be come into the comments part. Okay, let's hit the run button. Again, we are getting an end of the while passing this. Okay, let me. Why is everything okay now? Yeah, I think we are good to go. Okay, these 3 cases are accepted over here. Let's hit the submit button over here. Yeah, this is absolutely correct. So this is all about this particular problem. So enjoy Java. Okay everyone, just here